Jai Hind to all. Myself Shikha Agarwal, Assistant Professor in IT Department of Ajay Kumar Garg Engineering College. So, students, today we are going to discuss about one sorting algorithm, that is in heap sort. This is one of the very complex topic in data structures. So, before we start with the heap sort, we should know what do you mean by the term sorting. Basically, sorting means to rearrange the elements or to rearrange the given array or a list according to the comparison operator on the elements, right? So in this case, what do you mean by the term comparison operator? Basically, comparison operator is used to decide the new order of the elements in the respective data structure, whether the data should be in an ascending order or in descending order, but we have to rearrange into the sorted order, right? If I'm talk about the types of sorting, in the case of types of sorting, there are these are the different types of sorting, like bubble sort, selection sort, insertion sort, merge sort, quick sort, heap sort, and Reddick sort. Fine. Each and every sorting is having a purpose is similar, that we have to get the sorted data either in a ascending order or in descending order, but the method, the operating method is, or you can say the comparison operator is different in all these algorithms. And in this lecture, out of all these algorithms, we are going to discuss about the one complex topic, one complex algorithm, which is a heap sort, right? So we can say heap sort basically is based on a comparison based sorting technique, in which we have to based on binary heap, in which we are talking about the heap like a data structure. And basically it is similar to a selection sort, where we have to find the first minimum element or the maximum element and placed it into the beginning or the end of the order or of the list, depending upon which type of a sorting we are doing it, whether we are arranging the data in an ascending order or descending order. And we'll repeat the same process until and unless we will get the remaining elements to be in a sorted way, right? So if I'm talking about a sorting algorithm, there are certain characteristics, that it is an in place algorithm, that whatever the things we are doing it should always hold its own positions. Second thing, its typical implementation is not stable, but we can make it stable by applying the process, by doing the things. Typically 2 to 3 times slower than well implemented quick sort, and this is the reason it is a slowness lack in locality of reference. Little bit slow, but it is getting a desired output. Now, before we start about the heap sort, we should know what do you mean by the term heap, right? So in the case of heap, when we are talking about the heap, it is a complete binary tree. And what is the meaning of the word complete binary tree? It means each and every levels except from the last node is having a 2 child. Okay? So in this case, we can say, when I'm talking about the heap sort, the first thing is that it should a complete binary tree. And what do you mean by the term binary tree? Binary tree is that tree in which each and every node, it can have at most 2 children. Remember one thing, at most 2 children. And if I'm talking about a complete binary tree says in which all the levels except the last level, like I'm talking about the leaf node, should be filled completely, and all the nodes should have a left justified, right? So that is the way you are talking about the heap. When I'm talking about the heap, remember the two things. We are going to talk about max heap and min heap, right? If I'm talking about the max heap, remember one thing, in the case of max heap, always the parent node should be greater than its child node, right? So if I'm talking about an example, for example, if I say the root node is 80, then we can say the child is like 50 or 60. Again, if I'm talking about the 50 as a root node, then I can say 40 and 50, 49 can be the child nodes, because both are lesser than root node. Similarly, if I'm talking about the 62 child nodes, if I say 55 and 42. Both are the lesser than the above root node. This is the way how you are going to build a max heap. But if I'm talking about the case of min heap, in the case of min heap, remember one thing, that the parent's root value is always less than the child node. So for example, if I say the root node is 8, then we can say, for example, the child node is 10, 15, right? Again, if I say 10 is a root node, then I can say it can be 5, it can be 7. If I'm saying 15 as a root node, then I can say, for example, 11 or 12. Right? So this is the way how you can build a max heap or min heap, depending upon the given question, ki whether we are trying to build a max heap or min heap. You always work on a one thing, whether you are going for a maximum heap or for a min heap. Now, in this case, we are going to first of all think about the algorithm, how the heap sort will work. Remember one thing, heap sort is being applied on a given array, and into this we have to call a one function which is called as a build heap. How this will work onto it. When I'm talking about the heap sort, first of all we have to talk about the build of max heap array. We have to build the max heap. Then after that we have to talk about length of array up to 2. We have to execute the length, or we have to calculate the I from length of array till the second element. And in this case we have to swap the first element with the ith element, right? If we are talking about the heap size, then heap size minus 1, again we have to wait, and then after that we have to call the max heapify. So under the heap sort, we are going to talk about the two functions, right? First of all, we are going to talk about what do you mean by the term build max heap, right? In the case of build max heap, first of all you have to generate the max heapify. Into it, on the basis of that you have to calculate the build parameter. How you have to do it? When I'm talking about the heap size, it is equals to the length of the array. Suppose it is given that it is having 10 elements, so heap size will be 10. Fine. So into that case, you have to execute the length of array divided by 2, means to the half of it up to the 1 first element, and in which again you have to call the second function which is called as a max heapify, right? And max heapify function is called on I, because I value is depending upon this function. That is why we have to execute the function on array comma I. Now we know that this is the basic algorithm of heap sort, under which first of all we have to call the build max heap. In the case of build max heap, this is the function again into which we have to call the max heapify. Now we have to think about what is max heapify, right? In the case of max heapify, what we have to do it, first of all we have to take a one array into which the first element is I. Suppose I can show you an example. If I say this is an 80, right? Then after that if I say this is 60, and for example if I say this is 100, right? So if I'm talking about to call a max heapify onto this, suppose this is an array, like we have 80, 60 and then 100. Onto basis of that you have generated this tree, right? So if I say this is an I element, right? So this is a left of I and this is the right of I, right? So after that what you will do, you have to set L is equals to left of I. Then after that you have to set R is equals to right of I. Fine. Now what we have to do, we have to do the swapping. Swapping on basis on the largest element, right? For example, if I say if the left element is less than equals to heap size of an array, condition is true, or left of array is less than left of I, right? Then into that case what happens? Suppose मान के चलिए, into this case 80 is lesser than 60, for example. So we will do the swapping. Now largest is equals to L it becomes. If otherwise if it is not possible, then what is the largest element? Obviously I itself only. So in this case you can check L is smaller than 80. So into this case what we will do? We will not do the swapping, and simultaneously 80 will remain as the largest element. Fine. Now after that we will check from the R side. R side means we have to check it on the right hand side. Into the right hand side we have to check if AR is greater than AR largest. True. Then largest becomes R. So into this case this becomes 80 and this becomes 100. right? Then in the last, we have to check if the largest is not equals to I, right? If it is not equals to the I, then what we have to do? We have to do the swapping with the largest element. And what is the largest element? That is 100. So we did the swapping onto it, and again we will call to the max hippify on the again largest element. This is the way how we will call again and again the max hippify. Is it clear? Now you can see a one example. Suppose if I give you an array of these number of elements. So first of all, we have to generate the array. So into this case, we have to generate the array 8, 6, 1, 4, 3, 2, 9, 12, 5 and 7. Now after getting all these elements, what we have to do? We have to build a max heap. In the case of max heap, if it generated, it becomes 8, 6, 1, 4, 3, 2, 9, 12, 5 and 7. Fine. After generating the heap into the after generating into a tree form, you can check at most all the nodes is having the at most 2 childs except the leaf nodes, right? Then after generating it, we have to call the hippify function. What the hippify function says? That it will hippify calls equals to number of nodes divided by 2, right? So if the number of nodes I have to calculate, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. If suppose we have a 10 elements, so what is the hippify is to be called on? 10 divided by 2, that comes out to be on 5. So it means we have to call the hippify on 5th node. What is the 5th node? 1, 2, 3, 4 and 5. So it means onto this function, we will call a hippify a comma 5. And after calling into it, we have to check the max hippify function. Max hippify function says ki left child is greater or the right child, and we do the swapping according it. So into this case, 7 is greater than 3. So we will do the swapping. Now we will get the tree as 8, 6, 1, 4, 7, 2, 9, 12 and then 5, and finally it comes here 3. This is the way max hippify a comma 5 calls. And up to which level we have to call the hippify? Up to 1. From length of node divided by 2 till the 1, right? So again, now we have to call hippify 4. A comma 4. In the hippify a comma 4, it means we have to call the hippify function on this node because this is the 4th element, right? So onto this, we have to do the swapping. 12 comes on the 4th location and 4 comes on 12. So now the tree becomes 8, 6, 1, 12, 7, 2, 9, 4, 5 and 3. Now this is the tree. Then after that, we are going to call a hippify a comma 3. Onto a comma 3, it means we have to call it onto a 3rd function. While calling it onto the 3rd function, now I can generate a tree here. Into this case, the tree becomes 8, 6, 12, 4, 5, 7, 3, 8. Now 1 is lesser than 9. So it will do the swapping into this case, right? So it will becomes 9, then 2, then it will becomes 1. Fine. This is the way you will call to the hippify a comma 3. Now onto this tree, we will call an hippify a comma 2. When we call hippify a comma 2, now we have to check 6 comes onto the 12th location, right? And after 6, comparing it, 4 and 5 are smaller than 6. So 6 will hold its own position. Now the tree will becomes 8, 12, 9, 6, 4, 5. 7, 3, 2 and 1. Fine. After that, finally, we are going to call a Heapify a comma 1. When we call Heapify a comma 1, it means we have to call the Heapify function on 8th location. Now after that, the tree will comes out to be 12, 8, 6, 4, 5, 8, 7, 3, 9, 2 and 1. Now after getting this tree, it means you can see that we are getting the max Heapify. The top element is to be on the root node. Then after that you have to convert it into an array. Then it becomes 12, 8, 9, 6, 7, 2, 1, 4, 5 and 3. Right? So once you will build a tree, right? So it will becomes 12, 8, 9, 6, 2, 1, 4, 5, 3. Right? After that, what you have to do? You have to do the swapping of array A1 with AN. Right? Into this, you will do the swapping. Right? Once you will do the swapping, you will get an array as 3, 8, 9, 6, 7, 2, 1, 4, 5 and 12. Now the 12 will hold its own position. Right? Now you will apply the heap sort on n minus 1 elements. Right? When you apply the Heapify on the n minus 1 elements, it will become the tree 3, 8, 9, 6, 7, 2, 1, 4 and 5. Now you have to again call Heapify a comma 1 because we always used to call on array on the largest element. So we will call it as an Heapify a comma 1. When you call it on, you can check 9 is greater than 8 also and 3 replaced it. So we will do the swapping with 9. So it will becomes 9, it will becomes 3, 2 and 1. Then after that it is 8, 7, 6, 4 and 5. Now what you have to do? Again you have to do the tree. So it will becomes array 9, 8, 3, 6, 7, 2, 1, 4 and 5. Right? So again what you have to do? You have to swap A1 with AN minus 1. Into this swapping, now you will get an array as 5, 8, 3, 6, 7, 2, 1, 4 and 9. And in the last there was an element that is 12. So these two elements again holds the position. Now finally we have the array 5, 8, 3, 6, 7, 2, 1, 4. 4 and 9 and 12. But these two elements are already sorted. Fine. Now what we have to do? Again we have to build a heap sort. 5, 8, 3, 6, 7, 2, 1 and finally we are reaching to 4. Now please check the point carefully. Into this form, what happens? Now again we have to call Heapify a comma 1. When we call Heapify a comma 1, you can see 5 is smaller than 8, right? But when the 5 will comes here, 7 and 6 are greater. So what happens? It will do the swapping from 7 also. So into this case, now the tree becomes 8. It becomes 7. This is 5. This comes out to be 6, 4, 3, 2 and 1. Again we have to generate the array. That comes out to be 8, 7, 3, 6, 5, 2, 1 and 4. Right? We have to do the swapping with A, 1, 2 and minus 2. Right? So into this case, now we will get 4, 7, 3, 6, 5, 2, 1 and 8. And finally 8 also holds its own position. Right? Then again, by using this array, we have to generate the array that is 4, 7, 3, 6, 5, 2 and 1. Right? Now again onto this array, you have to call heapify. A comma 1. When you call heapify A comma 1, again you have to call it onto this. So 4 comes to be down and again 6 is greater. So again it will do the swapping with 6. So we will come out with 7, 6, 4, 5, 3, 2 and 1. Again we have to convert it into an array that comes out to be 7, 6, 3, 4, 5, 2 and 1. Swap. So we will get 1, 6, 3, 4, 5, 2 and 7. Again the 7 holds its own position. Right? Then after that again we will build the tree. That is 1, 6, 3, 4, 5 and 2. Right? Again we will call heapify on A comma 1. When we call it as, so it will swap with the 6, again it will swap with the 5. So it will becomes 6, 5, 4, 1, 3 and 2. Build a heap. 6, 5, 3, 4, 1 and 2. Swap. When we will do the swapping, we will get an array as 5, 3, 4, 1, 2 and 6. And finally 6 holds position. Right? Then the tree becomes 5, 3, 4, 1, 2. 5, 3, 4, 1, 2. Right? Now you can see the 5 is on the top of the element. So where there is no swapping, so again it will build the heap. Right? Build heap means 5, 3, 4, 1 and 2. Swap. When you will do the swapping, it will comes out to be 2, 3, 4, 1 and 5. 5 hold its own position. Right? Then again we have to generate the tree that is called as 2, 3, 4 and 1. Again when we will do the swapping, it comes out to be, we will call heapify A comma 1. When we call heapify A comma 1, it comes out to be 4, 3, 1 and 2. Again build a heap. 4, 3, 2, 1. Swap. So it comes out to be 1, 3, 2, 1, 4. Fine. 4 is hold its own position. Now we will left with 1, 3 and 2. 2. Now 3 will swap heapify A comma 1. So it will becomes 3, 1, 2. 3, 1, 2. Swap. So it will becomes 2, 1, 3. Again we'll build the tree 2, 1. Heapify. Same. So it will generate 2, 1. Swap. We left with 1, 2. We left with one node that is already sorted. Right? So this is the way we are getting a complete answer. That is 1, 2, 3. We are having 4, 5, 6, 7, 8, 9 and 12. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9 and finally we have 12. This is the way how we are getting a sorted array. Right? Fine. So this is the way how you need to calculate the sorted array. Fine. Remember one thing, when I'm talking about calculation of this example, first of all we have to calculate heapify on number of nodes starting from 5 till the length of A, that is from 1 up to 1. And after that again and again we have to call heapify A comma 1. Fine. Now remember one thing, into this when I'm talking about this max heapify, because every time we are going to call a max heapify on the largest. So into this case remember one thing, when I'm talking about a parent node, for example I, fine, so it always return I by 2. Right? If I'm talking about the left child is I, then we can say it will return 2i. But if it is a right child of I should be a right child, then it will return 2i plus 1. Okay? This is the way how the max heapify or heapify algorithms work. And this is the way how you have to solve the heap sort. After solving the heap sort, now you can try any number of questions also. Now, after solving this question, let's talk about the heap sort complexity. When I'm talking about the complexity, we know we are talking in terms of time and space, right? So when I'm talking about the heap sort, best cases, average case and worst case, in all the three conditions, the heap sort complexity is n log n in all the three cases. Why? Because the height of a balance tree, because it is a complete binary tree, and in a complete binary tree it always have a n elements, and if it is having an n elements, then it was always based on log n, due to which its time complexity is n log n. Right? Now after that, if I'm talking about the space complexity, because every time the one element holds its own position, right? So whatever the element is we have, it always holds a one element position, due to which its complexity is always 1, and there is no stable sorting into the case of heap sort. Now after that, let's talk about the certain advantages and disadvantages of heap sort. If I'm talking about the advantages of heap sort, there are the three main disadvantages of heap sort, that is efficiency, memory usage and simplicity. If I'm talking about the efficiency, the time required to perform the heap sort basically is increasing on log basis, right? While other algorithms, they are increasing the grow, or you can say on the basis of exponential growth, right? So this is why we can say it is more efficient. Second is, when I'm talking about the memory usage is minimal, because apart from whatever we are necessary to hold for the additional main list of the items, there is no need to additional space is required to hold the work. So that is why it is having a minimal memory usage. The next is simplicity. Simplicity because it is simpler to understand other than rest of the algorithms, because it does not use any advanced computer science concepts like recursion or tail recursion, anything they are not using it. There is a based on tree concept only, on the basis of complete binary tree only. But there are certain disadvantages of using the heap sort also. The first thing is heap sort is very costly because it is a very time consuming process, and whenever we are applying to it, it is costly. The next is unstable. Why it is unstable? It might rearrange the relative order also. So that is why we can say it is unstable. And somewhere, if I'm talking about its efficiency, if we are giving complex data sets, so somewhere it is not very efficient, right, for the complex data. Now, if I'm talking about the certain applications of heap sort, basically the heap sort is used in the hybrid algorithms like intro sort, right? And somewhere if we are sorting nearly sorted onto a k sorted arrays, k is we have to find the largest element or the smallest element into the array first. So these all are the applications of it. So in this lecture we have gone through a certain basics about the heap sort, and I've shown you an example also how the heap sort is being working, how its algorithm is working. You can try the more questions onto it and you can solve your problems. Thank you.